In this video, we will review adding and subtracting fractions. Adding and subtracting fractions can either be very easy or very complicated. It all depends on the fractions you have. In part A, we have 2/5 plus 6/5. Since these are both fractions over 5, we can simply add the numerators. 2 plus 6 gives me 8 over the common denominator of 5. If your fractions have a common denominator from the beginning, all you need to do is add the numerators. The same is true with subtraction. 9/4 minus 3/4, since they are both fractions over 4, the common denominator of 4 will carry through, and we subtract the numerators. 9 minus 3 is 6. As always, if we can reduce any fractional answers, we need to do so. In part A, 8/5 does not reduce, but in part B, 6/4 does. Both 6 and 4 are divisible by 2. 6 is 2 times 3, 4 is 2 times 2. So we can cancel out that common factor of 2, leaving us with a final answer of 3 over 2. The formal way that we mathematically state how to add and subtract fractions is to give an example that uses variables, but both fractions have a common denominator. So to add a over b plus c over b gives us a plus c all over b. In part B, we look at the subtraction version. A over b minus c over b, the common denominator of b carries through, and the numerator becomes a minus c. We write this way to stress the fact that for addition or subtraction of fractions to occur, you must have a common denominator. What do both of these operations depend on? Both addition and subtraction of fractions depends on the fractions having a common denominator. If they do not, converting either fraction to have a common denominator is always the first step. Now we'll look at some examples of addition and subtraction of fractions where the fractions do not have a common denominator. In our first example, part A, 5 over 2 plus 3 over 8. Clearly, 2 and 8 are not common denominators, so our first step here is to figure out what will be a common denominator for a fraction that has a denominator of 2 and a fraction that has a denominator of 8. We call this common denominator the LCD, the lowest common denominator. What we're looking for is the lowest number that is both a multiple of 2 and a multiple of 8. There are many ways to do this. Some of you have maybe learned about prime factorizations. Others might just simply start thinking about what are the multiples of 2, 2, 4, 6, 8, and you strike upon the fact that 8 is a multiple of 2. So the LCD in this particular situation is going to be 8. Once the LCD has been identified, you then need to determine which fractions need to be manipulated so that they will have that common denominator. The fraction of 3/8 already has the common denominator of 8, so we don't need to manipulate that one. But the fraction of 5 over 2 does not. So we ask ourselves, what would we need to multiply 2 by to make it become 8? Well, 2 times 4 is 8. But the way we manipulate fractions is we must multiply the fraction 5 over 2 by some form of 1. So if we multiply the denominator by 4, we also need to multiply the numerator by 4, because that red fraction of 4 over 4 equals 1, and by multiplying by 1 we're not changing the value, we're simply changing how it looks. We now need to do the multiplication first. 5 over 2 times 4 over 4. 5 times 4 is 20, 2 times 4 is 8. So we now have 20 over 8 plus 3 over 8. 20 over 8 is equivalent to 5 over 2, but it now has that common denominator that we needed. And now that both fractions are fractions over 8, we will write that as the common denominator in the final answer, and we add the numerators. 20 plus 3 is 23. In part B of this example, we have 14 over 9 minus 3 over 2. What we need to first do, to be able to subtract these fractions, is to find a common denominator for 9 and 2. We could begin the same way that we started with part A. We take the smaller number 2, and we start listing its multiples. 2, 4, 6, 8, 10, 12. You'll notice that we skipped over 9 because 9 is not a multiple of 2. So what we need to do is keep going until we find a multiple of 2 that is also a multiple of 8. Oh, I just skipped over 1 though. When we got to 18, 18 is a multiple of 9 and it is a multiple of 2. So the LCD in this particular case is going to be 18. We could have also seen that by simply multiplying the 2 and the 9 from the beginning. A fast way to always find an LCD is to multiply the two denominators together. It will not necessarily give you the lowest common denominator, but it will give you a common denominator, which is good enough to get started. We now need to turn both of these fractions, 14 over 9 and 3 over 2, into fractions that have a denominator of 18. So when I look at the 14 over 9, I begin by asking myself, what do I need to multiply 9 by to make it become 18? Well, 9 times 2 is 18. But if I multiply the denominator of this fraction by 2, I also need to multiply the numerator of the fraction by 2. Separately, I look at the 3 over 2 fraction. What do I need to multiply 2 by to make it become 18? Well, 2 times 9 is 18. But again, if I multiply the denominator of that fraction by 9, I also need to multiply the numerator by 9. We now complete the multiplications. 14 over 9 times 2 over 2 becomes 28 over 18. Separately, 3 over 2 times 9 over 9 is 27 over 18. And now that they are both fractions over 18, I will be able to subtract them. Again, the common denominator of 18 carries through to the answer. 28 minus 27 is 1. So the final answer here is 1/18.